Let's now look at the IEEE standards. The IEEE has a set of standards called the 802 standards, which are all about networking. And you can see that some of these, such as Ethernet 802.3, 802.3, is a wired technology. But wireless technologies, wireless LAN, in other words, Wi-Fi, is 802.11. The specialty networks, 802.15, that includes Bluetooth and Zigbee and so on. And then we have several others, 16, 18, 19, and 21, and 22, all have to do with wireless technologies. We're going to focus on 802.11. Now, you may already be aware, if you go to Walmart and look at the wireless routers there, that there is a letter after some of them. Now, let's take a look at those letters. Here's a whole bunch of them, and you're probably familiar with A and B, G, N, and AC, but what are all these other letters? Well, every time they want to make a new standard, they set up a working group to work on those standards. So, for example, the 802.11e has to do with something called quality of service, being able to filter certain kinds of traffic and give priority to certain kinds of traffic. 802.11j just happened, not by design, but just happened to have to do with some compatibility with Japanese standards. 802.11p I put down here has to do with vehicular environments. So not all of these are new versions of Wi-Fi, but almost all the letters exist. There are a few exceptions that don't, but most of them do. Now let's take a look at the important ones, the Wi-Fi, the major Wi-Fi updates and versions. And yes, you do need to know these numbers, although some of them are approximate. So for example, you notice I have approximate indoor range. Different articles, different authors will tell you different things because these are measured. They are not built in as standards, so they're just measured. But you should know these letters and what it refers to. So A is Wi-Fi 2, G is Wi-Fi 3, and so on. You should know the approximate data rates that they are rated at and the frequencies at which they work, and then probably the modulation type. You will need to know something about MIMO, but not all of the different flavors of MIMO. So let's just kind of survey these real quickly. First, there was 802.11 Legacy. This occurred in 1997 and sometimes known as 802.11.1997. Very, very, very slow, 1 to 2 megabits per second, not really practical. It was more proof of concept than anything. Ran on that 2.4 gigahertz range. That's because 2.4 gigahertz is unlicensed by the FCC, which means you don't have to have a license to operate radios in that range. It used a modulation type called FHSS, or Frequency Hopping Spread Spectrum, and then later was updated to DSSS, Direct Sequence Spread Spectrum. We will talk about these, all of these, OFDM and all these later on. So for now, just hold on to that thought. Approximate indoor range, only 66 feet. 802.11b came out before A, so that was what we called Wi-Fi 1. Very, very slow, 11 megabits per second. Operated at this 2.4 gigahertz range still, but did use the DSSS standard and got a little bit farther. 802.11a came out next, so we call that Wi-Fi 2. It just happened that the B working group finished before the A working group, that's all. And you got quite a bit faster. Why? Because of a jump in frequency. And remember that we said the higher the frequency, the more data you can cram into it. And so by increasing the frequency, we got higher data speeds, data rates. And we also went from DSSS to OFDM, which also helped. 100 feet, approximately indoor. There are outdoor standards that are different from indoor because you're allowed to use more power outdoors. 802.11g was next, and that was also 54 megabits per second, but actually dropped back down. Now, how in the world did it get the same rate even though it dropped back down? Well, it had to do with some improvements in the OFDM at the time, so we're not going to get into the technicalities of that. However, notice that it's not compatible with A. So it was quite not common for maybe a library to have a radio that handled B and G. Well, there was a problem with this. If let's say you had somebody in the library with a laptop that only ran B and somebody else with a laptop that ran G. Well, guess what? As soon as this B comes online, everybody slows down to 11 megabits per second. So here you've got this nice new, G 802.11g Wi-Fi card or laptop, and suddenly you think, man, I'm going to get these great speeds. And you go to the library and it just looks like it always did before. Well, that's because somebody is using B and it slows everybody down to B. We call it the killer B sometimes. It also used this OFDM, orthogonal frequency division multiplexing, but was able to get a little bit farther, again, by dropping the gigahertz, the frequency. We can get a little bit more out of it and still maintain the same speed here because of improvements in OFDM. The real big improvement was with N. Suddenly we doubled that to get to about 100 megabits per second. We called N Wi-Fi 4. It ran both 2.4 and 5 gigahertz, so it was compatible with all of the older standards. It used this high throughput OFDM. It was able to get a longer range, and it used something called MIMO. MIMO, multi-in, multi-out. We will talk about individually later on to see how it works. But MIMO is what gave it this huge boost here. Wi-Fi 5 802.11ac is what you can buy today, and you can get very, very fast speeds out of that. You can double N's speeds, or depending on what version of it you're using, you can get all the way up to 1.7 gigabits per second. You don't actually probably achieve that, but in theory you can. Again, we're using that 5 gigahertz. It's not compatible with 2.4, so it's not compatible with G or B, only with A or N when it's running in 5. It uses this very high throughput OFDM. You do lose some range, and you lose some of the range because, again, you're dropping back down. You can no longer use 2.4, and so with the higher frequencies, you get less range out of it. But these tremendous jumps here are due to an improvement in MIMO. So you have now MU-MIMO, multi-user MIMO, which really helps increase that speed. In the future is AX. We might be starting to see some AX soon if we don't already. We expect extremely high rates, 2.4 gigabits per second at the 2.4 gigahertz, and we don't know, at least I have not been able to find what form of OFDM it's using, so I can't tell you exactly why it's doing what it's doing because it's too new for us, but this is future. And then finally after that we expect BE, 30 gigabits per second. That will be Wi-Fi 7. I don't know that we'll actually ever achieve that. Right now it's iffy. That's their target, but it's iffy whether or not they can pull it off. It will begin to use for the first time this 6.0 gigahertz range, which the FCC is now opening up some of for unlicensed use in order to accommodate, well, mainly in order to accommodate 5G cellular, but will also allow some Wi-Fi. And it, by the way, a lot of the other types of radios will be banned from using it so that it keeps the traffic lower, and that should help. And it's supposed to use something called CMU MIMO. Again, we don't know very much about BE, and we barely know enough about AX. So this is where we are today at Wi-Fi 5, but we are looking forward to the future of that. All right, thank you very much.